car pulls a trailer along a straight road uphill on a slope that makes an angle of 5 degrees with the horizontal. The mass of the car is 1,800 kilograms and the mass of the trailer is 800 kilograms. The driving force is 8,000 newtons and the car and the trailer experience resistances of 1,000 and 600 newtons respectively. The coupling between the car and the trailer is light and parallel to the road. A. Draw a diagram showing all the forces acting on the car and all the forces acting on the trailer. B. Find the acceleration of the car and the trailer as they move up the hill. And C. Find the tension in the coupling between the car and the trailer. Okay, so we need to draw the diagram. So we want a 5-degree slope and 2 blocks to represent the car and the trailer. So the car will have a driving force of 800 newtons, have a normal reaction and a weight acting downwards, so 1,800 G acting downwards, and a 1,000 Newton resistance force, and also the tension in the coupling, which we eventually will have to find. For the trailer, it will also have the same tension in the coupling but going the other way. It will have a 800 G Newton force acting downwards and a normal reaction, which is different to this normal reaction, so we have to use some sort of different notation. We're going to call it RT for trailer. It also has a resistant force acting down the slope of 600 newtons. Also, we need to mark on the acceleration. So make sure the diagram is large and make sure it is clear. Right, so if we want to find the acceleration, then really we should just treat the system as one object. So now this represents both the car and the trailer. So we've got 800 acting downwards, the resistance acting upwards, a combined weight of 2,600 G newtons, and a combined resistance acting downwards 1,600 newtons, and the acceleration. So if we now resolve along the plane, so solving this way, we've got 800 minus 1,600 minus the component here. So the component here of the weight will be 2,000 G sine of 5 degrees. The angle is always the same as the angle of the slope. And that's equal to the mass, the total mass, times the acceleration. Rearranging that for A, we're going to get 8,000 minus 1,600 minus 2 times 2,600 G sine 5 degrees divided by 2,600 in kilograms. On my calculator, I'm going to get 1.607, which rounded off to 3 scientific figures is 1.61 meters per second. I can now use this in the next part of the question. So if we go back to the original diagram, now the easiest one to do is the trailer because it has less forces. So if we roll along the plane again, we're going to have T minus 600 minus 800 G sine of 5 degrees, and that's going to be equal to the mass, which is 800 times the acceleration I've just calculated. Rearranging that to find T, so everything just goes to the other side and becomes positive. That's going to give me 2,569.23 newtons, or 2,570 newtons. Now, I can check this by using this one here. If you don't have time in the exam, then you wouldn't have to do it, but it's a little bit more complicated. Here, revolving along the plane, I'm going to have 800 newtons minus T minus 1,000 minus 1,800 sine 5 is equal to 1,800 times 1.607. Making T the subject, well, the easiest thing to do is take this over to the other side, and then everything has the same sign. Again, if you work that out, it will give you the same value as you got here. If you don't get the same value, you've made a mistake. So the final answer will be 2,570 newtons. Okay, this has been a video to show you how to find the tension coupling on a connected object going up a slope. I hope you've understood, and I thank you very much for watching.